Welcome. In this video, we'll be looking at how to rationalize denominators. You might want to know what's the meaning of rationalization anyway, and why is something irrational to start with. We'll be looking at expressions where you have, let's look at an example here. You have square root of 7. Now, because 7 is a prime number, its square root actually has many decimals. I wouldn't have a guess of what it is, but its decimals actually never end, and they don't repeat themselves either. So 2.64, the answer is 2.64, and the decimals continue and they never repeat themselves. So this is the square root of 7. But when it's in the denominator of a fraction, that means that we are dividing 1 by an infinitely many decimal numbers. Now, computers, if they have to store this value, actually they run out of memory and they have to approximate answer to this problem. And so, and if they had to evaluate this, we would have to be dividing forever because the decimals never end. So, rationalizing means that making sure that our denominator is not a square factor. It doesn't have a square root in it. Therefore, somehow we have to remove the square root. That's the meaning of rationalizing the denominator, or rationalizing surds for that matter. So, if we know that the square root of 7 times the square root of 7 will give us a positive 7, which is what we want. We can divide by 7, that's fine. So to rationalize, we take the denominator and the numerator and we multiply both top and bottom by the same factor. That would leave the original fraction unchanged, because we are doing what we're doing to the top, we are doing the same thing to the bottom. So this fraction has a value of 1, so ultimately it wouldn't change the original fraction. Then, once we perform our calculation, we end up with root 7 in the numerator, but the denominator is a rationalized number, or a rational number. Alright, let's look at the harder example here. You remember factorizing difference of two squares that came up to be like so? We're going to use that here. If you have expand the bracket here, if you've been asked to expand the bracket here, what you end up with is a plus root 3 and a minus root 3 in the middle, because I used the conjugate of the first bracket here. This was a plus, but I wrote it as a minus. This is called writing its conjugate. So 1 minus 3 is minus 2. So the answer to this multiplication here, or these multiplying these two brackets, is actually a minus 2. Why do we care about that? Because sometimes you have denominators like so. What you need to do is actually multiply the top and the bottom by the conjugate of the denominator. So that means making sure that the sign actually flips. So if there's a plus root 3 in the denominator, we write it like so, so that in the denominator, just like on the left hand side, we already worked out, the denominator is going to be a minus 2. Now, the fact that you multiplied 5 by these two terms gave us 5 minus 5 root 3. Dividing by negative 2 means that we can write 5 over 2 with the as a minus 5. That's that. That's the first two terms here. And dividing a negative by a negative will give us a positive. So that's why I took the liberty of rewriting that fraction as a fraction like so. Alright, have a think about this, and then we'll go through another example. So what I said was that if you have a plus sign in front of the square root, you're gonna take the opposite sign in the and multiply the top and bottom by this factor here, bracket. And if you have a minus sign in front of the square root, you take this factor and multiply top and bottom by this. Let's see. Alright, this is the simplest example. So you simply multiply by root 3 times root 3 over root 3. You end up with this expression here. Then pause the video and have a go at this problem and play again. So I hope you've had a go at this. You end up with this expression here. Then going through the motions and multiplying, you end up with 2 will cancel away because of the plus and minus sign, and you end up with this expression here. Alright, so there are some other variations of these problems. Sometimes you see something like so, and you think, alright, I'm just going to multiply by what? What do we multiply to simplify this expression? Well, the denominator has a minus sign in front of it, root 2, so you take its conjugate and it will be like root 5 over plus root 2 over root 5 plus root 2. So then going through the motions and expanding the bracket, you end up with 7 over 3. 7 plus 2 root 10 over 3. Okay? Now, this bracket has a square on it. So don't be fooled by thinking that, oh, I'm just going to take the conjugate. This means that first you have to actually go through the bracket expansion and simplify it. So 1 minus root 3 has to be multiplied by 1 minus root 3. There is no other way of going about it other than going through the process itself. What you end up with is this expression. Now is the time where you take the opposite sign conjugation and multiply the top and bottom by 4 plus 2 root 3 over 4 plus 2 root 3. You end up with, after you go through the motion, you end up with these expressions. Take your time and think carefully how we got each term. 4 times 4 is 16. Then 4 times root 2 over 3 and 4 times negative root 2 over 3. That means that these two terms will cancel. And finally, 4 times square root of 9 is 4 times 3, which is with a minus sign in front of it, is a minus 12. So 16 minus 12 is a 4. Then actually you look at the common factors here. You can factorize a 2 out of each term. And write it like so. Make sure you don't solve it like so. Make sure you factorize and write factors nice and neat, because this is a nicer way of showing you're working out. Alright, so happy practicing. I'll see you in the next video.